Hi children, good morning. How are you? How you have done your exams? I think very well. Most of the children still you have to submit your papers. Come and submit fast. You don't want any result? You want no? So you have to submit the papers in the school. Okay? Then welcome back to our session. So what class is this? This is our science, that too physics class. So in our previous chapters we have learned many things, is it? Yes. So today's our chapter is we are going to learn about some natural phenomena. What's our chapter? Some natural phenomena. What is this? Means naturally which it is occurring for us. What is that? It's nothing but wind, storms, lightning, thunder. These and all will be happen naturally. We cannot expect the things. Is it? Yeah. See our state nearby Kodagu district and what is that? Madikeri, so much rains and the land it has gone and some of the houses it has destructed. Is it? So these are the natural things without knowing us it is happening. Is it? So in this chapter we are going to learn about the lightning, thunder, how it is going to come. What are the things it happens when the lightning is going to occur. Okay. Then, have you seen the lightning, children? When it occurs? When the rain starts, you have to see the clouds, very black clouds, and the light also will be very dim. It gives so much of cool air for us. Is it? Yes, when the rain starts, it shows a lot, it gives for us a lot of sound. That is nothing but thunder. What is that? It's the thunder, and with the thunder, very bright light will be given for us. What is that? It's the lightning. Yes, exactly. How it happened so? Anybody are going to keep the light for us? It's impossible. So, lightning, how it is going to come for us? What do you mean by the lightning? Let me see now. Yes. What is lightning? The bright flash of light which we see in the clouds is called lightning. What do you mean by lightning? The bright flash of light which we see in the clouds is called lightning. So when we see to the sky, what is that? Very fraction of seconds it comes and go. So that one only we call it as the lightning. So how it will be? Like this it will come. So like this branches and all it will be. Is it all right, children? Yes. So within the seconds, if it comes and if you want to see also immediately, we will close the eyes. We cannot see. Actually, we should not see that one. It's very effect for our eyes. So the bright flash of light which we see in the clouds is called as lightning. Lightning is an electric charge. What is that? It is an electric charge in the atmosphere between oppositely charged clouds. So, one and the both. How it should be? Oppositely charged clouds. So, one should be the negative and one should be the positive. When the opposite clouds, it is going to meet. That means dash together, we can see the lightning. Or between charged clouds and the earth. For the charged clouds and the earth also, it will be possible to see the lightning. Okay? So, this is about our lightning. Now, we have talked about the electric charge. That means the lightning is responsible for this electric charge. What do you mean by electric charge? Electric charge is the property of matter which is responsible for electrical phenomena. So, what do you mean by electric charge? The electric charge is the property of matter which is responsible for the electrical phenomena. So this electric charge exists in the two forms, that is positive electric charge and negative electric charge. For this I can give one example with children. Take a comb and comb your hair. So when the hair is while you are combing, the hair will be moving like this. So it is having such a charge. That means when we are combing. So if you are not understanding, take a comb. First of all, comb your hair and take a small pieces of paper and keep that comb towards to the paper. It is going to attract it because of this electric charge. Because of the electric charge. Sit on a chair, keep your legs up, ask your friend or your sister or brother to beat with the towel. So if you keep the legs down, you will feel the shock. If you are not keeping the legs down, those who are beating to you, they will feel that somewhat they are getting the electric shock. This and all is the responsible for the electric charges. I think you have done that while combing the hair. So no need of comb also. In our classrooms we will be having a scale. Yeah, take a scale or take a pen and take the pieces of the paper. So small pieces of paper we have to take it. So if you do like this, the small pieces of paper, see I have taken very small pieces. Can you observe? Yeah. So just take your pen and do like this. We have to do like this and just keep it like this. Yeah, you can see the attraction of the paper towards the pen. Yeah, see here children, you can see the paper. Yeah, so here also this is going to act as the positive or else it shows for us the negative also. So see now also, yeah, it is attracting. So what we call for this? We call it as the electrostatic force. Which type of force is this? Electrostatic force. Okay. So by this I'll show you a small video for you children. So see the video and understand what do you mean by the lightning and what is the electrostatic force. So by this let me end up the session and tomorrow with the new topic let me come. Until that, what I have given the points you have to note down in your homework note or running notes while coming to the school. You have to show. Don't neglect these points children. Okay, thank you.
When dazzling streaks of light flash across a dark sky during a rainy day, accompanied by thunder, it is known as lightning. Sometimes sparks are generated on an electric pole when wires become loose. This phenomena is quite common when a strong wind is blowing and shaking the wire.
The story of lightning. In 1752, Benjamin Franklin observed a miraculous phenomenon when he was flying a kite during lightning and thunderstorm. He attached the kite to a silk string and tied an iron key at the other end. He tied a thin metal wire from the key and inserted it into a leaden jar, a jar used for storing electric charge. He attached a silk ribbon to the key. Benjamin flew the kite by holding onto the silk ribbon. After some time, when he brought his knuckles near the key, he saw an electric spark between the key and his knuckles. Electricity from the clouds passed through the string to the keys, his knuckles, and finally to the earth. Franklin's experiment showed that lightning was static electricity.
Lightning occurs when there is a charge separation in the cloud. As a thunderstorm grows, electric charges build up within the cloud, with positive charges at the top and negative charges at the bottom. Clouds get electrically charged because of the presence of friction between the wind and the clouds. An American scientist, Benjamin Franklin, showed that clouds have electrical charges.
Negative and positive charges. Take two glass rods and rub them with a piece of silk cloth. Suspend one rod with a silk thread to a stand. Bring the other glass rod near it. You will observe that the suspended glass rod moves away from the other glass rod. Take a glass rod and rub it with silk cloth. Suspend it with a silk thread. Take an ebonite rod and rub it with a piece of fur. Bring this ebonite rod near the suspended charged glass rod. You will observe that the suspended glass rod gets attracted towards the ebonite rod. From the above activity, it is clear that there are two types of charges. Conventionally, the charge acquired by glass rod when it is rubbed with silk is called positive charge. Thus, the charge acquired by ebonite rod when it is rubbed with fur is called negative charge.
When two appropriate substances are rubbed together, the substances get electrified, that is, acquire an electric charge. We can prove this with the help of an activity. Take a comb and rub it on dry hair. Now, bring this comb near bits of paper. You will notice that the comb attracts the bits of paper. Now take a glass rod and rub it on silk cloth. Place glass rod against inflated balloon. You will notice that the balloon sticks to the glass rod. So, we can conclude that the effect of rubbing is to produce a type of force which acts from a distance, and this force can attract as well as repel bodies. It is known as electrostatic force. The comb and the glass rod have acquired electric charge. Thus, such bodies are said to be electrically charged. When two appropriate substances are rubbed together, the substances get electrified, that is, acquire an electric charge. We can prove this with the help of an activity. Take a comb and rub it on dry hair. Now, bring this comb near bits of paper. You will notice that the comb attracts the bits of paper. Now take a glass rod and rub it on silk cloth. Place glass rod against inflated balloon. You will notice that the balloon sticks to the glass rod. So, we can conclude that the effect of rubbing is to produce a type of force which acts from a distance, and this force can attract as well as repel bodies. It is known as electrostatic force. The comb and the glass rod have acquired electric charge. Thus, such bodies are said to be electrically charged. Take an empty jam bottle, as shown here. Take a piece of cardboard slightly bigger in size than the mouth of the bottle. Pierce a hole in it so that a metal paper clip could be inserted. Hang a paper clip as shown here. Cut two strips of aluminium foil about 4 cm by 1 cm each. Hang them on the paper clip. Insert the paper clip in the cardboard lid so that it is perpendicular to it. Charge a refill by rubbing it with silk cloth and touch it with the end of the paper clip. We observe that electrical charge can be transferred from the charged object to another through a metal conductor. Now, touch the end of the paper clip gently with hand and you will find a change in the foil strips. They come back to their original state. This is because the foil strips lose charge to the earth through your body. We can now say that the foil strips are discharged. The process of transferring of charge from a charged object to the earth is called earthing.
Electroscope. Take a gold leaf electroscope. Take a glass rod or plastic scale and rub it with a silk cloth so that it gets positively charged. Bring the charged glass rod or plastic scale near the brass disc of the electroscope and touch it. You will observe that the gold leaves inside the electroscope diverge. This happens because on touching the charged rod with the brass disc, the charge flows from the rod to the gold leaves along the brass rod. Since both the gold leaves carry the same charges, they repel, thus diverge. Next, touch the brass disc with your hand. The gold leaves collapse and come back to their original position. This happens because the gold leaves lose charge to the earth through your body, as the human body is a good conductor. As seen in the above activity, the charge on the leaves goes into the earth through your body. The leaves are then said to be discharged. The process of transfer of charges from a charged body to the earth is called earthing.
When two clouds with unlike charges come very close to each other, a huge spark is produced between the clouds, and this spark is known as lightning. Sparking discharge can occur not only between two clouds but also between a charged cloud and the earth as shown here. Some safety measures against lightning are given here. An appropriate shelter could be a building or a car with the windows closed. The body of the car acts as a conducting path for the lightning bolt, and thus the person inside the car is safe. It may be ensured that all tall buildings are fitted with metal lightning conductors. This is done to direct lightning harmlessly to the ground. Carrying an umbrella is not safe during thunderstorm. One must stay indoors during a thunderstorm and switch off computers, TV, electric iron, etc. A pointed metal rod is fixed upright on the building.